This is review worksheet for 4.1 through 4.4. We're going to look at the following function, and we're going to determine if it opens up or down. Since the a value is less than 0, we know that it's going to open downwards. This asks if it opens up or down, so it opens down. To find the line of symmetry, there's a couple different ways we could do it. The common way we did if it was in standard form was to use negative b over 2a, negative the b value, so negative 4 over 2 times a gives you 4 over negative 4, which gives us negative 1. So x equals negative 1 would be your line of symmetry. To find your vertex, in this case it would be a maximum value. You would need to plug negative 1 back into your equation. So our equation was y equals negative 2. We plug in the negative 1 squared minus 4 times negative 1 plus 4. When you square your negative, you get a positive. So positive 1 times 2, positive 4 plus 4 gives us a final answer of negative 2. So your vertex is negative 1 comma negative 2. Here we're going to use the line of symmetry and the vertex and some reflection points to graph. So we're going to start out with negative b over 2a, and that means that we're going to get negative 2 over 2 times 1, which gives you negative 1. That is your line of symmetry. So write out your equation for line of symmetry. Plug that line of symmetry back into the equation. So we get 1 minus 2 minus 3, which is a total of negative 5 plus 1, which is negative 4. So when x is negative 1, we're down at negative 4. That is your vertex. So the vertex is negative 1 comma negative 4. So we found the line of symmetry. We found the vertex. Now we're going to test a point. One easy point to work with is negative 3, because that is called your line of, that is your y-intercept. And we can reflect that point right across. So we have a reflection point at negative 2, negative 3. Now we're going to test our point by plugging in any additional point we wish. So I could look for x equals 1. When you plug in x equals 1, we get 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3 gives us 0. So at 1, we're going to be at 0. So that's 2 units away from the line of symmetry. So I'm going to go 2 more to the line of symmetry. So now we're able to graph it, and we write our equation. X squared plus 2x minus 3. This one's going to be a little trickier looking. It looks intimidating with all the fractions. We're going to look at our line of symmetry, which is negative b, which is negative 2, over 2a. So the a value is negative 1/2. So we get negative 2, negative 1, so your line of symmetry is at 2. Graph out your equation of x equals 2. Now we need to figure out where the vertex is at. We notice that the a value is negative, so we know that it's going to be a maximum value, but that still doesn't tell us where it's located. So we're going to plug in the number 2 into our equation. Half of 4 gives us negative 2. Negative half of 4 is negative 2. That would be 12 halves. So it was going to be negative 5 halves, which is 2 1/2. So we found out where our vertex is at. The vertex is at the line of symmetry, and at positive actually that'll be at negative 5 halves. And then we look at our line of symmetry, which is at x equals 2. Our y-intercept something's backwards here. And what seems to be the problem is that our equation for our line of symmetry is negative b over 2a. So we get negative b. My b value is actually negative 2. So when I calculate that out, I actually get a positive 2, which should give me a negative 2 for my line of symmetry. X equals negative 2. So now we have to plug in our negative 2, which is 4. Our negative 2 puts us in a plus 4. When you take half of 4, you get negative 2. Here we get 2 plus our 3 1/2, puts us at 5 1/2. That's off our chart. But now our y-intercept is up at 3 1/2. So it's 2 units to the line of symmetry and 2 units past that. We can even test a point to say what happens when x is, we'll have fun and say x is 2. Half of 4, negative 2, and this is where we were getting negative 5 halves. So that point existed, it just wasn't just where we thought it was. And it's 1, 2, 3, 4 points to the line of symmetry. So this graph would actually be falling off. So this problem's falling apart on me. But it is graphed correctly now. A candy store has about 380 members and charges each member $35 a year. The owner estimates that there will be 15 more members for every $2 that we reduce the price. We're going to write an equation of the function in standard form. So we need to recognize that revenue deals with the number of people that you have times the price. So the revenue is 380 times our price of 35. So that's going to give us a profit of 13,300. Let's try it again. What's happening to our membership? The owner estimates that there will be 15 more members when you reduce the price. So we have 380. We're going to increase by 15 members every time we increase or decrease the price. So we're going to take our $35 and we're going to decrease it by $2 every time we increase by 15. So here's our equation. So to put it into standard form, we would multiply the front, the outer, the inner, and then the last. So our final equation here is negative 30x squared minus 235, because that's the collecting our like terms, plus 13,300. That's our equation. Now, what price do we need to maximize it? We can either use negative b over 2a. That would tell us the amount that we're changing by. So negative 235 divided by 2 times a. We're going to get an x value of almost 4. The numbers don't work out really nice for this one. So we're getting negative 3.91. So that if you think about what's being drawn here, if our line of symmetry is back here, with the maximum value, because our A is negative, we know right here is 13,300. In a real world situation, that's our maximum value. We can't go to a negative amount that we're working backwards. So the maximum is to the left of us rather than to the right. Not a greatly written question. So I tested out my line of symmetry. I got negative 3.91. That's off to the left. So my maximum point is not in the first quadrant. My highest point would be this 13,300. So no change in price is going to maximize this equation. We're going to graph the function using the parent function, which you got to watch where your origin is located. 1 over 1 up, 2 over 4 up. It's y equals x squared. And then we're going to do the reflection. Which there is none because there's not a negative in front with the A. We're going to do a stretch. Which there is none because you stretch by a factor of 1. Your translation, 1 unit right, two units down. It'll always be the opposite of what's inside your parentheses. So take each of your points, move to the right 1, and down 2. You can use different colors, which would be fabulous. Label your equation. The parent is going to be y equals x squared. So we label that on our graph. Reflect over x-axis. Which means you're going to open it downwards. Which is y equals negative x squared. And you're going to translate it 2 units left. There's no stretch. So we'll go to the left 2 units, down 1. And write our equation. To write the equation in standard form, we need to write the quantity that's being squared twice. We're going to FOIL through to x squared minus 4x plus 16. Collect your like terms. Now you cannot add the 2 to the 16. You have to distribute this guy through, and then we can add the 2. So your equation that would match this would have a C value of 50. On this, we would multiply through, FOIL the front, the outer, the inner, and the last. Collect your like terms. And then distribute. It's in standard form because it's in the format of ax squared plus bx plus c. On the next side, we are to find the minimum or maximum value of the function. We notice that this is in vertex form. Because it has parentheses, it has a square. Inside, you have your h value that's going to be -3, and your k value that's going to be -2. So your vertex is going to be at -3, -2. Your a is less than 0, so you have a maximum, and the maximum has a y value of y equals -2. Here we have intercept form. This is crossing the x-axis. That's why we call it intercept. It's the intersect of where the graph touches the x-axis. So thinking about what the graph looks like for this, x-axis, y-axis, you're going to be at -4, you're going to be at +5. So to find your line of symmetry, we do the LOS, P plus Q divided by 2. So the P is -4, the Q is 5, so we get a half. That's your line of symmetry. We know that the vertex is on the line of symmetry. The minimum or maximum is where the vertex is located. So we have to plug our half back in. So we'd get 9/2. This would be 10/2, -9/2. Crazy set of numbers here. So we're going to get 7 times -81/2. That's where our y-intercept, or our maximum value, will be located, which is at -283.5. So because a is greater than 0, we have a minimum value with the y value of -283.5. It's such a squirrely-like number because the a value is so large, it's so narrow, but the x-intercepts are so spread apart. We're going to solve the equation. You can solve the equation multiple ways. The way that we've learned recently is by factoring. So we're going to factor this guy. We're going to take our a times the c to get 12. Adds to be 8. We know that the two signs either both have to be positive or both have to be negative. I'm going to point out that they both need to be positive because they add to be a positive. So if you don't recognize what the factors are right away, we would start out with 1 times 12 makes 12, 2 times 6 makes 12, 3 times 4 makes 12. The 6 and the 2 are the only way that we can get to 8. So we can solve this now by factor by grouping. You may use the box if you wish. We look at the first two numbers, we look at the last two numbers, we factor out our x. Bring down your sign, factor out the 2. Remember what's inside the parentheses has to be exactly the same. So we get x plus 2, 3x plus 2. So this is going to come out to be x plus 2 equals 0, so x equals -2. 3x plus 2 equals 0. Subtract the x, divide by 3. We get -2/3. Here we're going to bring all the terms to the same side. We notice that you cannot divide the 3 into all 3 terms. So we're going to get 90 by doing our A times the C. We know that both terms have to be positive because it multiplies to be a positive and adds to be a positive. So we get 1 and 90, 2 and 45, 3 and 30, 4 doesn't go into that, 5 goes into that, 18 times, there's your 23. So we could do the box. When we work with the box, we put the 3x squared, put the 30, our 5x, and 18x, factor out a 5, 3x. So our final answer here, in terms of factoring, is 3x plus 5 and x plus 6. That still equals 0 if we're supposed to be solving. So we're going to set your first monomial equal to 0. This is called the zero product property. Get negative 5 divided by 3. On this side you get negative 6. Those are your 2 zeros of the function. Those would be called your 2 roots. Those would be called your x-intercepts. The dimensions of the old sandbox at my apartment is 12 feet wide and 10 feet deep. So we have 10 and we have 12 feet wide. The new mega sandbox will have twice that area. The dimensions of the new mega sandbox are created by adding. So the new one's going to be bigger, and we're going to add an x value to each of the dimensions. So when we look at this, we currently have an area of 120. So we know that an x on either side is going to give us 2x plus 12. Up and down is going to give us 2x plus 10. That needs an area. The new sandbox has to have an area that's 2 times the 120. So we'll say 4x squared plus 20x plus 20x plus 120 equals 440. 4x squared plus 40x minus 120, because when you subtract the 440, you're going to get negative 120. You look in here, you see that 4 can come out. So what multiplies to be negative 30 and adds to be 10? Well, when we look at this now, we see that we're not going to be able to multiply to be negative 30 and add to be 10. So these particular numbers are not working out the way they're supposed to. It's not that it doesn't have a solution, it's just that this equation is not factorable. The x value that would work with this equation we'll be able to solve using quadratic formula in the future. Write the equation in intercept form, then find the zeros of the function. Write it in intercept form just essentially means that you are going to factor out the problem. So we get 2x squared and we get 6x. And then to find the zeros of the function, you want to know when does your equation equal 0. So this is intercept form. So we can set 2x equal to 0 and x plus 3 equal to 0. Those are my zeros of the function. We get negative 36 that adds to be 5. That's going to be 9 and 4. It's going to be a positive 9 and a negative 4. And you could move on and use the box if you wish. Just say 3x squared minus 12. You could use factor by grouping also if you desire. We get 9x, and we get negative 4x. So we'll factor out a 3, factor out an x, factor out a 3x, factor out a negative 4. Because the box is negative, that number is going to be negative. So we're going to get 3x minus 4 and x plus 3. We can check our work. We get 3x squared. We get 9 minus 5 is 9 minus 4 is positive 5 and a negative 12. So we'll equal that to 0. Set them equal to 0. Those are the two zeros of the function.